Okay, so open channel flow. Now we'll try to get some understanding about the open channel flow. So far we know internal flow and external flow. So some of you can mix it with internal flow. Actually, internal flow we know some sort of pipe flow, but here when we're talking about the open channel flow is kind of flow which is open to the atmosphere. That means it is kind of the channel flow where the top surface is open and we have a air water interface, kind of the we can see on top of the flow like this one. You look at this picture, so the top surface, this is open, so we can say this is open channel flow. On other hand, when we had the internal flow, we say this is the pipe, so the flow is just going inside the pipe. So yeah, but there is very small differences. The flow through the conduit, it could be open channel flow depending on if it does not fill completely the fluid. If the fluid does not fill completely, let's say we have a conduit like this, so the flow is going through left to the right, and the half of this, it is actually filled with the fluids. So that means the rest of the section here, this is open, so we can see some sort of the air, atmospheric air, these sections. So we can say this is also the open channel flow. So the basic difference between the internal and external flow is the internal and the open channel flow is said, for internal flow it should completely fill with the fluid, but for open channel flow, the top surface should be open, or the conduit should be partially filled with the fluids. So when for pipe flow, the internal flow, we had the gravity and the pressure difference, where when we have the channel, it is the open channel, it is just driven due to the gravity. We'll discuss it later on. So in this case, it is actually the flow is happening due to the gravity. So we can say here the open channel flow, this is the flow in a channel which is the top surface is open or partially filled conduit. So you can see these definitions, and this is, we can say, the open channel flow, and the top surface, and we can say this is the free surface where the liquid, this surface, we can say this is the free surface. So there are a lot of examples we have in real life, like the flow in rivers, river flow, or the flood flow due to the floods, creeks, the rain or the drainage systems. There are a lot of things. Some man-made sources like the irrigation system, the seal lines. So a lot of things we have in real life. So the most importantly, we know the pipe flow, the internal flow, but now when we have this the open channel flow, so this is, we can say, our system, and this is not moving, the flow is actually moving. So this is static, the flow, it is just moving. This is a static object, let's say this is the canal or the system. So in this case, in this open channel, we will see the velocity at these walls, the left to right walls, that means here, okay, and the bottom surface, this is 0. You all know this is a static object, so when the fluid particle does this, it will be completely stops at the near this wall. That means the side walls, like the left and the right side and the bottom wall, the velocity will be 0. We'll experience maximum velocity at the center. That means you can say it's very close to this open surface, or it should be mid-plane if this is a symmetric object. It is asymmetric. You can see this geometry, this is symmetric, this cross-sectional view, it is just symmetric. If I draw a line here, so this is just half, this is another half. But if it is asymmetric, then we'll get some different flow patterns. You can see this is showing actually the flow streamlines. So what we said for open channel flow, the velocity at the near wall, the left, right and the bottom wall, it should be 0. And here you can see some example of the open channel flow where the the fluid is connected, kind of open to the atmospheric air. So you can see these two pictures here. So depending on the system, this flow, it could be uniform or it could be non-uniform. So simply, if this is you know the 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 system where the flow is going this way, you see it's a little bit of inclined. It makes kind of an angle, a slope, theta. It's very small slope here. So what we can see, this shaded zone, this is the flow zone, that means this is the fluid. So this is the normal depth. What you can see, this normal depth, it is actually constant. This y, it is actually constant throughout this system. So if the flow depth, okay, this flow depth is constant throughout the systems, okay, then we can say this is uniform flow. If it change, then we can say this is non-uniform flow. And this depth, it is called the uniform depth, normal depth. So we'll discuss it a bit more in the next videos. So what we said, if the flow depth is constant, then it is uniform flow. If it is not constant throughout the system, throughout the channel, then we can say this is non-uniform flow. So that's it, and yeah, we'll discuss a bit more in the next video.